Welcome back. We're ready to do part D, and let me copy and paste that in as well. Copy and paste. See, I don't think that's going to need this graph, so let me just remove that with a color other than yellow. There you go. And let me copy and paste it. This copying and pasting, I don't know if you can read it, but it's helpful for me to view the problem on our clipboard. Okay. The rate, let's see. Okay. The rate at which tickets were sold for t, for over this range, is modeled by R of t. Let me write that in case you can't see it. This is the rate at which tickets were sold. R of t is equal to 550 t e to the minus t over 2. Tickets per hour. Based on the model, how many tickets were sold by 3 p.m.? So t equals 3 to the nearest whole number. So that's sometimes important. You don't want to give a decimal answer. So this is the rate at which tickets are sold, right? So this is the derivative of the total tickets sold function, right? Or another way we could write it is the total tickets sold. So let's call that, I don't know, capital T sub, well, I don't want to do T of T, that just looks weird. So let's say the tickets sold as a function of time is going to be equal to the definite integral. Well, you could say at any time t, the tickets sold, and this is the fundamental theorem of calculus. I think it might be one of its corollaries, or actually sometimes it is the fundamental theorem of calculus. I always forget my definitions. But it's between time equals 0 and t, or if we want to know the tickets sold between time equals 0 and t is equal to the integral of the rate at which the tickets sold was changing. So that's equal to 550 t e to the minus t over 2 dt. Alright, that's it. And so if we want to know how many tickets were sold at time equals 3, that's just equal to the definite integral from 0 to 3, or we could also view it as the area under this curve from time equals 0 to time equals 3, of 550 t e to the minus t over 2 dt. Now this integral right here, you can solve it analytically using integration of parts, which I just call the reverse product rule. But you only have 45 minutes to do all three of these problems, and they'll let you use your graphing calculator. And your graphing calculator is excellent at doing definite integrals, and they just want the number, right? So let's use our graphing calculators to get that number. So let's see. I don't want to copy. I don't want to. Let's see. So how do we do that? We just do the division button, but that's calc. Definite. Let me use it. The definite integral. And like what was? Let's see. Let me make sure I have that. So it's 550. Let's just use x. 550 times x times second e to the minus x divided by 2. I think that's the whole function, right? That's the whole function. And let's see, my independent variable is x. I just swapped t for x there. And I'm taking the integral from 0 to 3. Click enter, let the calculator do the work. This would have taken you quite a while if you had to actually do the integral yourself. 972.78. And they want us to round to the nearest whole number. So the nearest whole number is 973. So we say 973 tickets sold by 3 p.m. And we're done. That only took us 4 minutes. And it would take us even less if we didn't have to explain it. Anyway, I will see you in problem number 3.